Hello. Today we will start Chapter 3, which is Logic, and we will talk about Section 3.1. So this is mostly going to be basic vocabulary, learning what the symbols are, how to write things in symbolic versus English notation, so using symbols instead of words, or using words instead of symbols. Next time we'll talk more about truth tables, and then we'll talk about arguments and stuff like that. But for today, it's mostly just vocabulary, making sure that we know what all the symbols mean and how to use them. So the first symbol that we're going to talk about is negation. So negation. So the thing with negation is that usually people think of this as like bad, right, or like negative, and kind of it is, but when you think about a negation in math with numbers, if the number's positive and I negate it, then it becomes negative, and if it's negative and I negate it, it becomes positive. So really when we're talking about negation, we're talking about the opposite. So I'm going to say, what was it to start with? And what's the opposite of that, right? So the symbol that we use for this is the tilde, so the squiggly line like this. And then the word that we often see with this is not. So in example 1, we have some statements, and we want to write the negations of these. Again, all I want to do is to make the meaning the opposite of what it is to begin with. So the first statement says, Fred did his research paper. So if I want the opposite of him doing the paper, that just means that he didn't do it, right? So the negation of Fred did his research paper would be Fred did not do his paper. So similar to that, if this is an example of an equation, if I want this to be the opposite, this would not be an example, right? So this is not an example of an equation. And so now you have to be careful because the last one says my car is not working. So the opposite of it not working would be that it does work, right? So my car is working. So not too bad, right? We're just doing the opposite of what we started with. Unfortunately, it's not always this easy. So sometimes it's a little bit harder to decide the negation of something, right? So what we need to think of here are words that are called quantifiers. So quantifiers give a quantity, an amount of things, right? So these would be words like all things or everything or some things or no things, right? So I'm giving some kind of quantity to that. So what you need to think about is what it really means to be the opposite of all. So if I were to say that all people at Blinn College want to go to Texas A&M. That would not necessarily be true as long as there was one person here that didn't want to go, right? So the opposite of all the people here wanting to go is not that nobody here wants to go. It's just that there's at least one person that doesn't want to go, right? So the opposite of all is not none. The opposite of all is that some do not, right? And so that means that since things in math, when they're equal, right, go both ways, that if some people do not, the opposite of that would be that all of them do. Because if I said some don't, obviously if some don't, some do. So those can't be opposites of each other, right? Because if there's 10 people and 5 don't, 5 do, right? So it's not good enough to say that some do. It would have to be that all of them do. So that also means that if nobody at Blinn wanted to go to A&M, the opposite of that would not have to be that everybody does. It would just be that there's like at least a few people here that do, right? So the opposite of none or no is just that some do. And again, it works both ways. So if the opposite of some would be that none do. So the hardest part here is that some is used twice. right? It's some or it's some do not. So you have to be careful and look for this extra not somewhere in the sentence, right? So here we go. Let's write some negations. So the first one says no rational number is irrational. So we know that the opposite of no is some. So that means the opposite of no rational number is irrational would be just that some rational numbers are irrational. For the next one, it says every chef knows how to boil water. So the opposite of all or every is that some do not, right? So some don't. So the opposite of every chef knows how to boil water would be that some chefs don't. Oh, don't know how to boil water. So in the third one, some numbers are not prime numbers. So it starts with some, yes, but it also has not. So the some not, the opposite of that is that all do, right? So some numbers are not prime numbers. The opposite would be that all numbers are prime numbers. And the last one says that some trees are always green. We only have the word some. There is not a not, right? So this goes with the no or the none. It doesn't really make sense to say none trees. So we're going to say no trees are always green. So these are usually the harder negations. I would suggest maybe making some flashcards so that you can make sure you remember which ones are the opposite of each other, right? So if I ask you in my math lab or on your exam that you're sure to remember which ones are the opposite of the other. So now that we've talked about negation, let's talk about conjunctions. So the conjunction, the symbol for this is kind of like an A. Let me draw a better one. Kind of like an A or an upside down V, right? That's the symbol. The words for this are and, but, however, things like that, right? So things that mean they happen together. I want this and this. I want this, but not that, right? I want this, however, this comes with it, right? So those kind of words that link things together. So what we're going to do in example 3 is we're going to take words and we're going to rewrite them as symbols. So the first step to this is to give each simple statement, so individual piece, a letter. And then once we give the letter there, then we can look for what our words are that link, right? And so in this case, we're looking for that conjunction since that's what we're talking about. And then we'll write it just as the symbols. So symbols are nice in logic because in logic, usually we're trying to verify whether or not something is true. And when you use words, people have emotions that are attached to words, right? So if I gave you an actual statement, you may have some emotional tie to the words in that statement. But if I remove the words and just give you a symbol, then you can more logically evaluate, right, whether those symbols give you a true and valid statement or not, right? So we remove the emotion from it and we give only the basic mathematical logical answer, right? So we're going to write the following conjunction in symbolic form. So this says Kanye is not on tour, but Kanye is recording a new CD. So again, but, this is our conjunction, right? So I have two things happening here. I have Kanye is not on tour. So the not is a negation, right? So be careful with this one. Not is a negation. So that means that for my first statement P, we're going to say that Kanye is on tour. And then for my second statement, so after the but, Kanye is recording a new CD, so that would be my Q. Kanye is recording a new CD. Okay, so those are my two simple statements. Now we're going to put it all together using my symbols, right? So again, we said that Kanye West is not on tour, so I actually want the negation of P, because P is that he's on tour, so negation, not on tour. But that's my conjunction. And then he is recording a new CD, and so Q. And then this is what this statement would look like in symbolic form. So again, we've removed all the words, we've removed all of the emotions that could be tied to those words, and now we can evaluate the statement just as it is, right? In example 4, we're going to talk about disjunction. So the symbol for disjunction is like a V. This is an inclusive or, and so what that means is it's kind of like an and slash or, right? So even if it doesn't say and or, we're going to assume that it means and or, that I could have both or I could have one or the other, right? So in this class, we will always assume inclusive or unless specifically said not to, right? So again, we're just going to write the following disjunction in symbolic form. So Camilla will not take chemistry, or Camilla will take French. Again, be very careful. We've got a couple of things happening here. We have the negation, the not. Here's my or, my disjunction, right? So now I can write my two statements. I've got P, and this is Camilla will take chemistry. And then Q, Camilla will take French. And now I can write my complete statement. So we are not taking chemistry, so I want the negation of P, or we will take French, Q. And again, I am done. So in example 5, we're just going to use the conjunction and the disjunction together, but what we need to talk about here are commas. So commas are used to group simple statements together. So the way that this works is everything on one side of the comma will go together and everything on the other side will go together. Be very careful. The connective after a comma does not go in the parentheses. Okay, so this is just like an English language convention where often the connective will go after the comma, But when we write this statement logically, that connective, so my conjunction or my disjunction, will actually go outside the parentheses that we use to group, okay? So be very careful with that part. So if I want to write the following statements in symbolic form, dinner includes soup and salad or veggie of the day. We need some simple statements. So this time I've got 3, right? I've got soup, salad, vegetable. So we're going to have a P. So dinner includes soup. I have Q. Dinner includes salad, and I have R, dinner, capitalized, includes veggie of the day. So those are my 3 individuals. So again, what we're going to look for here, dinner includes soup, comma, and salad or vegetable of the day. When I use this comma to group, the only thing on the left is dinner includes soup, right? So outside of the parentheses, I'm going to have dinner including soup. And then I'm going to group the salad and the veggie of the day together. So when I write this symbolically, P is dinner includes soup, so that will go first. And that's my conjunction. And then I put my parentheses. Dinner includes a salad, that was Q, or that's my disjunction. Dinner includes the veggie of the day, and that's R. So now we know how this works, right? When I get dinner, I'm definitely getting soup, and I have a choice between the salad or the vegetable of the day, right? So order of operations, I do inside the parentheses first, right? So I have to make my choice. Do I want a salad or do I want the vegetable of the day? And I also get soup with that, right? So in part B, we have the exact same words. We just have changed where my comma is, right? So this says dinner includes soup and salad or vegetable of the day, right? So this time, the things that I have together, dinner includes soup and salad, right? That's my parentheses. So everything on the left goes together, or it includes the vegetable of the day. So when I write it this time, I still start with the soup, the P, and the salad, the Q. That's in parentheses, or I get my vegetable of the day, R. So all I've done is change where the parentheses are, but now this means something totally different. Let's make that look more like an A instead of A. Because now it says inside parentheses, I get soup and salad, or I could have the vegetable of the day, right? So now when I go to eat at this restaurant, I'm either getting soup and salad together, or I just get the vegetable of the day. In part A, I had the choice between the salad and the vegetable of the day, and I also got soup, right? So just by changing where that comma is, where those parentheses go, changes how things are grouped together and changes the meaning of the sentence.